Like wires in the electrical system, the vacuum hoses in our vehicles have grown large in number, especially with the addition of emission controls. Today, there are at least 6 vacuum hoses leading from the carburetor alone, with others directly connected to the intake manifold. In fact, some 1975 models have as many as 12 vacuum systems. To better understand what these systems do and how they work, we'll trace the vacuum lines of the various systems and describe the functions of the components they operate or control. Heater and air conditioning vacuum systems will not be covered here. In the positive crankcase ventilation, or PCV system, incoming air picks up residual fumes and vapors inside the engine as it's drawn through into the intake manifold. The air passes out through the PCV valve and its hose, which is attached to the PCV connector at the carburetor. The PCV valve reduces ventilating airflow through the system at idle to keep it from leaning out the air-fuel mixture, and increases the flow at higher engine speeds for maximum crankcase ventilation. The evaporation control system is designed to store fuel system vapors when the engine is stopped, and to purge these vapors when the engine is running. Vapor expansion in the fuel tank, and on some models inside the carburetor, forces fuel vapor through connecting lines into a storage canister located in the engine compartment. When the engine is running, air is drawn through a filter into the storage area of the canister, where it picks up fuel vapors. The air and vapor continue on into the intake manifold through a hose which leads to the purge connection at the base of the carburetor. In the heated inlet air system, manifold vacuum is routed from a connection at the base of the carburetor through a hose to the temperature sensor valve in the air cleaner housing. A hose from the valve leads to a spring-loaded vacuum diaphragm on top of the air inlet snorkel. When underhood air temperature is under 10 degrees above zero, diaphragm action opens the air inlet from the manifold heat stove, blocking the snorkel entrance so all inlet air flows through the stove. Between 10 and 90 degrees, diaphragm action allows proportional flow through both air circuits to modulate inlet air temperature. Above 90 degrees, all inlet air flows through the snorkel entrance. The orifice spark advance control, or OSAC system, delays vacuum timing advance for NOx emission control. A plain black vacuum line leads from the carburetor spark advance port connection to the bottom of the OSAC valve on the air cleaner housing. And from the upper valve connection, a red stripe hose leads to the vacuum unit on the ignition distributor. The OSAC valve is essentially a two-way control orifice which delays vacuum advance action when the throttle is opened from idle position, but permits instant changes when throttling down. In addition to the OSAC valve, some models also have a thermal ignition control, or TIC valve, to prevent engine overheating at idle or low running speeds. Here we have the same OSAC valve connections, but the red stripe hose runs to the top connection at the TIC valve, with a red dash hose from the center connection to the distributor, and a yellow stripe hose from the bottom connection to the intake manifold. When engine coolant temperature reaches 225 degrees, the TIC valve routes full manifold vacuum to the distributor. This advances the timing, which speeds up the engine to increase cooling action. Normal OSAC operation is restored when the temperature drops below the critical point. The exhaust gas recirculating, or EGR system, is a throttle-controlled vacuum circuit which operates a manifold valve to dilute the air-fuel mixture with exhaust gas for NOx emission control. Two systems are used depending on engine model and transmission type. In the ported vacuum control system, a yellow stripe hose runs from the EGR vacuum connection at the carburetor base to an EGR time delay solenoid valve on the right bank of the engine. From the solenoid, a blue stripe hose leads to the coolant control EGR valve in the top of the radiator. For convenience, we'll call this the Kager valve. From the Kager valve, a white stripe hose completes the circuit to the EGR valve on the manifold. Each time the engine is started, the EGR delay timer energizes the solenoid valve, which then blocks vacuum to the EGR valve. This temporarily prevents exhaust gas recirculation to improve hot engine starting and operation. The Kager valve in the radiator also delays EGR valve operation by cutting off the vacuum when coolant temperature is below 75 degrees. In the 360 V8 two-barrel installations, the Kager valve is located in the water jacket of the intake manifold and closes when engine block temperature is below 130 degrees. Along with the EGR system, and new on 75 models, is the idle enrichment system, designed to temporarily enrich the idle mixture to improve cold starts and warm-up performance of engines with automatic transmissions. In the idle enrichment system, used with ported vacuum control, a plain black hose leads from the intake manifold to the idle enrichment solenoid valve at the rear of the engine. From the solenoid valve, a green stripe hose leads to the coolant control idle enrichment valve in the intake manifold. We'll call this the CC valve. From the CC valve, a pink stripe hose runs to the idle enrichment valve connection on the carburetor. A filtered air bleed prevents vacuum from being trapped in this hose. In other models, the CC valve is located in the engine block water jacket or in the coolant pump housing. The CC valve in all federal requirement engines allows idle enrichment system operation only when engine coolant temperature is below 138 degrees. The EGR delay timer energizes both solenoids each time the engine is started. The EGR solenoid cuts off vacuum to the EGR valve. And at the same time, the idle enrichment solenoid applies vacuum to the valve in the carburetor. When the timer cuts off the solenoids, EGR vacuum is restored and the idle enrichment vacuum is shut off. The Venturi vacuum control system is similar to the ported control system, but a vacuum amplifier is added. Here, a yellow stripe hose runs from the carburetor Venturi connection to a multiple connector at the amplifier. From the connector, an orange stripe hose leads to the EGR time delay solenoid valve. And from the branch connection on the other end of the solenoid, a plain black hose leads to the intake manifold connection. The other solenoid connection completes the circuit with a green stripe hose to the CC valve and a pink stripe vacuum air bleed hose to the carburetor. The remaining blue stripe hose from the amplifier connector leads to the Kager valve in the top of the radiator. And a white stripe hose from the Kager valve leads to the EGR valve on the intake manifold. In this system, the EGR solenoid controls both EGR and idle enrichment operation. The Venturi vacuum control EGR system on engines with the manual transmission is essentially the system just described, less the idle enrichment feature. California requirement engine installations have a minor difference in the CC valve connections. Here, instead of connecting the rear end of the green stripe hose to the EGR solenoid, it is teed into the black manifold hose. This means that the idle enrichment function on these models is controlled solely by the CC valve, which is designed to shut off enrichment system vacuum when engine block temperature is above 86 degrees. The vacuum circuit in the air injection system used on some models leads directly from the intake manifold connection to the system's diverter valve, which is designed to prevent backfiring in the exhaust system. When the throttle closes suddenly, the sharp increase of intake vacuum moves the diverter diaphragm upward. This causes the valve to vent injection pump output, bypassing the exhaust manifold, where the injection air could combine with unburned deceleration mixture and cause a backfire. The power brake vacuum hose leads directly from the intake manifold to the connector on the power brake housing. Pressure on the brake pedal opens a valve inside the unit, admitting atmospheric pressure, which moves the vacuum diaphragm to assist pedal pressure in applying the brakes. The speed control vacuum hose connects to a branch of the power brake vacuum hose connector. The combined action of a mechanical governor and a solenoid valve in the speed control servo operates a control valve. This valve either applies manifold vacuum or vents the chamber to operate a diaphragm connected to the throttle cable, which regulates engine speed. The automatic vehicle height control system vacuum circuit operates a compressor, which furnishes air pressure to raise the air chamber type rear shock absorbers used with this system. The operation of this system is covered in MTSC session 75-7. As with the speed control system, the vacuum hose for height control connects to a branch of the power brake unit hose connector. The parking brake vacuum release system automatically releases the parking brake lever when the transmission is shifted into any gear with the engine running. The vacuum hose from the intake manifold leads to a vacuum switch on the steering column. A second hose leads from the valve to the brake lever release actuator on the lever mounting bracket. When the switch arm is moved by shifting the transmission selector, vacuum is applied to the brake lever actuator. The actuator unlocks the brake lever ratchet, allowing the lever spring to retract the lever. The operation of any vacuum system can be affected by incorrect connections, disconnected hoses, hose leaks, or blockages. Engine idle operation is also affected by air leaking into any vacuum system. Common symptoms of vacuum hose-caused problems are slow or erratic component operation or rough engine idle. If a hose is split, hardened, softened, or otherwise deteriorated in any way, it should be replaced. Be sure to use the correct size and type of new hose, especially when replacing the fuel-resistant hoses in the evaporation control system. And that's our story. Vacuum system component testing procedures are covered in the service manual. You'll find additional system servicing information in the reference book for this session and on the vehicle engine compartment hose routing charts.